Yesterday, our entire lesson hinged upon the fact that our figures were similar. If our figures were not similar, if they were not proportional, then throw everything we did yesterday out the window. Remember, yesterday we used the fact that the ratio of the sides was A to B, the ratio of the perimeters was A to B, and the ratio of the areas was A squared to B squared. So 1D, 1D, 2D. And we were allowed to go back and forth squaring and square rooting things. But that was only if our figures were similar. Do you remember that sign that means similar? Okay. Now today we're going to talk about, because in the real world, honestly, the changes are not always going to be proportional. Sometimes they will not be proportional, but we still want to know what happens to the area. So let's say an architect is designing a room. Sorry, I use my husband's job every time. So he's designing the third story of an office building. And he's trying to figure out if he wants to make the space for where they put the desks for their office, if he wants to make it a little bit longer. Make it a little bit longer. He doesn't want to double the dimensions of the room. That's not practical. He doesn't have that much space. But he wants to know, okay, if I give them this much more, if I extend it by, let's say, 8 feet, how much more room will there be for people to put their desks? So it's talking about what happens to the area if I change one of the dimensions. I'm not going to change the length and the width. I don't have the space for that. But what if I extend it by a little bit? What effect will it have on the area? What happens to the area? Okay? Good? Okay. So we're going to discover, but we're not going to use an index card today. We're going to pretend. Okay. So yesterday, you were given an index card. We found the dimensions of the index card. Let's write them down. It was 3 by 5. The perimeter was 16 inches, and the area was 15 inches squared. Okay, now let's find out what happens if we doubled our width. We'll do our width this time. We'll double our width. So same index card. Put another index card, and now I doubled just the width. I'm not doing it proportionally. These are not similar figures. I want you to go ahead and find the area and perimeter of my new card. The entire card right here. So I want to know if I double one of the dimensions, what happens to the area and the perimeter? Go ahead and calculate that. Okay, so what are our new dimensions? 6 by 5, yeah? Okay, what's our new perimeter? 22 inches. And what's our new area? Now, what today is all about is not learning a trick. Today is not about learning a shortcut or a trick. Today is about changing something and then realizing what happened, realizing how you affected things, okay? So when we changed one of the sides, we extended one of the sides, the perimeter, because we extended the side that was 3, well, a rectangle has 2 widths, right? So we extended 3 and 3 on both sides, so our perimeter increased by 6. Our area, on the other hand, our area doubled because we doubled the width. Had we doubled the length and the width, the area would have been times 2, which would have been quadrupled like yesterday. But since we only messed with one of the dimensions, it was simply times 2. What if we did, here's an example of if we had doubled the length instead of the width. Okay, if we double the length, let's see. The length was 5. So how is the perimeter affected? There's 2 5s. There's 2 lengths. So the perimeter is affected by 10. It's 10 more. And how is the area affected? Whoa, No change there. So if I double just one of the dimensions, I double the area. So nothing changed there. Okay? Let's try a couple of examples and then we will play Wheel of Fortune. It's not always plus 10. It just happened to be plus 10 because the sides were 5. When we had changed the width, it was plus 6 because 3 plus 3 is 6. 5 plus 5 is 10. There's nothing you can memorize. You just have to solve each problem like it's a new problem. Shucks. Sorry, 2/5 the size of the original. When it's a fraction and the numerator is smaller than the denominator, it means the shape got smaller. So the scale factor is 2/5, and how much did you lose? 900 square meters. Moral of the story, there's no trick. You just solve the first one, solve the second one, and find out what happened. Last example, really short lesson today, right? And then we'll play. If a rectangle's, oh no, not again. Original dimensions are a length of x plus 10 and a width of x plus 2, how does the perimeter change if the length is changed to x plus 15? This one I feel like we could do the long way, but then we could do it a short way, and I'll show you how in a minute. This one, the longest way possible, would be to draw a picture, calculate what's it asking for. It's asking for the perimeter, right? And then draw another picture. So I think that would be the long way. Then you make an observation. What happened to the perimeter? It increased by 10. Not by 10x. The x's didn't change. 4x, 4x. It increased by 10 units because we weren't given units. But I could have figured that out by looking at the problem and seeing, oh, this is all that changed. And remembering, okay, so it increased by 5, but a rectangle has 2 lengths, so 5 plus 5 and 10, bada bing, bada boom, right? So you could have just said, oh, the length increased by 5, there's 2 lengths, 2 times 5. True or false? A rectangle has a certain length and a width that creates a perimeter of 40 inches. If the length doubles, then the perimeter doubles. The answer is, of course, false. What we don't care about was the 40. The 40 had nothing to do with the problem at all. We learned today that if you double just one of the dimensions, it doesn't do anything in particular to the perimeter. It doesn't double the perimeter. It doesn't necessarily, well, it will double the area, but we're not talking about that. It doesn't do anything necessarily to the perimeter. It might increase the perimeter by 6. It might increase the perimeter by 10. We would need to know the length in order to tell you that. So either way, the answer is false. Doubling just one of the dimensions does not double the perimeter. The scale of two similar triangles is 1 to 3. If the area of the smaller triangle is 15, what's the area of the larger problem? Guys, this is the whole reason we did yesterday's lesson. Oops. Oh no. The whole reason that we did the note card activity is that when you doubled the dimensions of your note card, when you put 4 of them together, you didn't double the area, you quadrupled the area. It had a doubling, a squared effect. If your area is 15 and your scale factor is 3, you don't triple the area, you triple the sides, you triple the height, you triple the perimeter, you triple anything that's one-dimensional, but you do not triple the area. These need to match. Those need to be twins. And so, to make them twins, you don't multiply it by 3, you multiply it by 9. Just like when we doubled the note cards, it wasn't by 2, the area was multiplied by 4, 2 squared. So the final answer is 135 inches squared. A square had its dimensions doubled, so doubled means times 2, and that's its dimension, so it's 1D. What is the length of the sides of the original square? So we know perimeter is 1D, so we can use this scale factor. The dimensions were doubled, so we do the opposite of doubling something. We need to divide by 2. That will undo the doubling. So the perimeter of the original square is 28.8. But it's not asking for the perimeter, it wants a side, and we know a square has 4 congruent sides, so we can split this into 4 equal parts, and that's where we get 7.2 inches.